Are you ready to master the future of technology? Autonomous systems are redefining industries from self-driving cars to automated factories. But passing the certification exam requires more than just basic knowledge. It requires a deep understanding of AI decision-making, sensor fusion, and safety protocols. In this video, we will cover AI autonomous systems certification practice questions, comprehensive exam prep. Prepare for your AI autonomous systems certification with this comprehensive practice exam video. In this video, we break down 30 high-quality practice questions designed to mirror the actual AI autonomous systems certification. We cover everything from perception and localization to path planning and ethical AI governance. Before we dive into the first question, make sure to grab a notebook and see how many you can get right. Don't forget to subscribe for more expert-level AI training content. Which sensor technology is primarily used for generating high-resolution 3D point clouds for spatial mapping in autonomous vehicles? Option A. Ultrasonic sensors. Option B. LiDAR. Option C. Passive infrared. PIR. Option D. Monocular cameras. The correct answer is B. LiDAR. Light detection and ranging. Works by emitting pulsed laser light and measuring the time it takes for the light to bounce off objects. This allows the system to calculate distances with high precision, creating a dense point cloud that represents the 3D environment. Unlike cameras, LiDAR is not dependent on ambient light, making it robust in various lighting conditions. While monocular cameras can estimate depth using software, they do not natively produce 3D point clouds with the same geometric accuracy as LiDAR. In the context of SLAM, simultaneous localization and mapping, what is the primary purpose of loop closure? Option A. To ensure the robot returns to its starting point. Option B. To reduce accumulated drift and error in the map. Option C. To close the electrical circuit of the sensors. Option D. To speed up the processing of sensor data. The correct answer is B. As an autonomous system moves, small errors in odometry and sensor readings accumulate over time, leading to drift, where the estimated position deviates from reality. Loop closure occurs when the system recognizes a previously visited location. By matching current sensor data with historical data from that location, the system can calculate the total error accumulated since the last visit and propagate corrections backward through the map. Pose graph optimization, effectively snapping the map into a more accurate alignment. Which algorithm is commonly used for finding the shortest path in a discrete grid-based environment, while utilizing heuristics for efficiency? Option A. Dijkstra's algorithm. Option B. A** search. Option C. Breadth first search. BFS. Option D. Random walk. The correct answer is B. A is an extension of Dijkstra's algorithm that uses both the actual distance from the start, g cost, and an estimated distance to the goal, h cost, or heuristic. This allows A** to prioritize exploring paths that are more likely to lead to the destination quickly, making it significantly more efficient than Dijkstra's or BFS for path planning in autonomous systems where real-time performance is critical. BFS explores all neighbors equally, making it inefficient for large maps. What is the primary advantage of using a Kalman filter in an autonomous systems navigation stack? Option A. It compresses video data to save bandwidth. Option B. It provides an optimal estimate of a system's state by combining noisy measurements. Option C. It acts as a firewall against cyber attacks. Option D. It replaces the need for GPS entirely. The correct answer is B. Autonomous systems often deal with noisy data from multiple sensors, e.g., GPS, IMU, wheel encoders. The Kalman filter is a mathematical method that uses a series of measurements observed over time, containing statistical noise and other inaccuracies. It produces estimates of unknown variables that tend to be more accurate than those based on a single measurement alone by estimating the joint probability distribution over the variables for each timeframe. It is the backbone of state estimation in robotics. Which of the following describes the OEDR, object and event detection and response, in the context of autonomous driving? Option A. The ability of the car to connect to the internet. Option B. The monitoring of the driving environment and executing appropriate responses. Option C. The process of charging the vehicle's battery. Option D. The registration of the vehicle in a government database. The correct answer is B. OEDR is a fundamental functional requirement for autonomous vehicles. It encompasses the system's ability to detect objects, pedestrians, other cars, debris, and events, traffic light changes, sirens, sudden braking of the lead car, and respond to them appropriately. Braking, steering, accelerating. For a vehicle to be considered Level 4 or Level 5 autonomous, it must be able to handle the OEDR within its operational design domain. Odd. Without human intervention. In a PID controller, what does the integral I component primarily address? Option A. Predicting future errors. Option B. Reacting to the current error magnitude. Option C. Eliminating steady-state error over time. Option D. Reducing the speed of the system. The correct answer is C. A PID, proportional integral derivative, controller is a control loop feedback mechanism. The proportional part reacts to the current error, while the derivative part predicts future errors by looking at the rate of change. The integral component sums up the past errors over time. Its main job is to eliminate the steady-state error, which is a persistent difference between the desired set point and the actual value that a simple proportional controller cannot overcome on its own. Which phenomenon causes radar to detect the speed of an approaching object by measuring frequency shifts? Option A. The Doppler effect. Option B. Photoelectric effect. Option C. Refraction. Option D. Diffraction. The correct answer is A. The Doppler effect is the change in frequency or wavelength of a wave in relation to an observer, moving relative to the wave source. In autonomous systems, radar sensors use this effect to instantly measure the relative velocity of other vehicles or objects. If an object is moving toward the sensor, the frequency of the reflected radio waves increases. If moving away, it decreases. This is vital for adaptive cruise control and collision avoidance. In high-speed autonomous racing, why might a model predictive control (MPC) approach be preferred over a simple pure pursuit algorithm? Option A. MPC requires less computational power. Option B. MPC accounts for vehicle dynamics and future constraints. Option C. Peer pursuit is only for underwater vehicles. Option D. MPC only works with lidar data. The correct answer is B. Peer pursuit is a geometric path tracking algorithm that calculates the curvature required to reach a look-ahead point on a path. While simple, it ignores vehicle dynamics, like tire slip or mass. Model predictive control, MPC, however, uses a dynamic model of the vehicle to predict future states over a time horizon. It optimizes a cost function while respecting constraints, like maximum steering angle or traction limits, making it far superior for high-speed or complex maneuvers where physics cannot be ignored. What is the defining characteristic of an end-to-end learning approach in autonomous systems? Option A. It uses separate modules for perception, planning, and control. Option B. It maps raw sensor input directly to control commands, e.g., steering, using a single neural network. Option C. It only works with manual gearboxes. Option D. It requires the system to be turned off at the end of every trip. The correct answer is B. Traditional autonomous stacks are modular, meaning they have distinct blocks for perception, seeing, localization, knowing where you are, and planning, deciding what to do. In contrast, end-to-end learning uses a deep neural network, often a CNN or transformer, trained to take raw input, like camera images, and output control signals like steering angles or acceleration directly. While harder to interpret and debug, it can potentially find efficiencies that modular systems miss. Which neural network architecture is most commonly used for semantic segmentation in autonomous perception? Option A. Recurrent neural networks, RNN. Option B. Generative adversarial networks, GAN. Option C. Fully convolutional networks, FCN. Option D. Boltzmann machines. The correct answer is C. Semantic segmentation is the process of labeling every pixel in an image with a class, e.g., road, sky, pedestrian. Fully convolutional networks, FCNs, or architectures like UNet and DeepLab are preferred for this because they replace the fully connected layers found in standard CNNs with convolutional layers. This allows the network to output a spatial map, the same size as the input image, rather than just a single classification label, which is essential for understanding exactly where the road ends and the sidewalk begins. What does the ISO 26262 standard specifically address in the automotive industry? Option A. The fuel efficiency of internal combustion engines. Option B. Functional safety for road vehicles, electrical and electronic systems. Option C. The aesthetics of the vehicle interior. Option D. The maximum speed allowed on highways. The correct answer is B. ISO 26262 is the international standard for the functional safety of electrical and/or electronic systems in production road vehicles. It defines the automotive safety integrity level, a SIL, which ranks the risk of a system failure. For autonomous systems, adhering to ISO 26262 is critical because it provides a framework for identifying hazards, assessing risks, and verifying that the AI and hardware components are reliable enough to prevent catastrophic accidents. What is late fusion in the context of multi-sensor perception? Option A. Combining raw data from all sensors before processing. Option B. Processing each sensor independently and combining their high-level detections. Objects. Option C. Waiting until the end of the trip to analyze data. Option D. Using only one sensor if others fail. The correct answer is B. Late fusion, or object-level fusion, involves running independent detection algorithms on each sensor, e.g., a camera-based object detector and a lidar-based object detector. The outputs, bounding boxes or tracked objects, are then fused together using methods like Kalman filters or Bayesian logic. The advantage is that if one sensor's raw data is noisy, it doesn't immediately corrupt the entire pipeline, and different sensor modalities can be weighted based on their reliability in specific conditions. Which of the following is a disadvantage of relying solely on GPS for autonomous vehicle? Localization? Option A. GPS is too expensive for consumer cars. Option B. GPS signals can be blocked or reflected in urban canyons. Option C. GPS doesn't work during the daytime. Option D. GPS only works for flying drones. The correct answer is B. Standard GPS, GNSS, often lacks the centimeter-level accuracy required for lane keeping. Furthermore, in urban canyons, areas with many tall buildings, or tunnels, the signal can be blocked, loss of lock, or reflected off buildings. Multipath error. This causes the estimated position to jump significantly. Therefore, autonomous systems must fuse GPS with IMU data and visual lidar-based localization to maintain a consistent and accurate pose. In the dynamic window approach, DWA, for local obstacle avoidance, how is the best velocity selected? Option A. By picking a random speed and direction. Option B. By searching the velocity space reachable within a short time interval and maximizing an objective function. Option C. By always choosing the maximum possible speed. Option D. By following the velocity of the vehicle directly in front. The correct answer is B. DWA is a local path planning strategy. It considers the current dynamics of the robot, acceleration, deceleration limits, to define a dynamic window of reachable velocities. It then samples velocities within this window, simulates the resulting trajectories for a short time, and scores them based on factors like distance to obstacles, progress toward the goal, and speed. The velocity with the highest score is executed. This allows for safe, real-time reactive navigation. What is the primary role of an IMU, inertial measurement unit, in an autonomous system? Option A. To capture high-definition photos. Option B. To measure acceleration and angular velocity. Option C. To detect the color of traffic lights. Option D. To provide internet connectivity. The correct answer is B. An IMU consists of accelerometers, which measure linear acceleration, and gyroscopes, which measure rotational rate, angular velocity. By integrating these measurements, the system can perform dead reckoning, estimating its position and orientation between GPS or visual updates. This is crucial for maintaining localization during high-speed maneuvers or when other sensors momentarily fail or experience high latency. In a finite-state machine, FSM, for an autonomous vehicle, what is a state transition? Option A. The physical movement from one city to another. Option B. The logic that moves the system from one behavior, e.g., lane keeping, to another, e.g., intersection handling. Option C. The process of updating the software. Option D. A change in the car's paint color. The correct answer is B. A finite state machine, FSM, is a model of behavior composed of states and transitions. For an autonomous vehicle, states might include idle, cruising, following lead vehicle, or emergency brake. A transition occurs when a specific condition is met, e.g., a red light detected event triggers a transition from cruising to stopping. FSMs are popular in robotics because they are predictable and easy to verify, though they can become complex in highly dynamic environments. Why is rectification an important step in stereo vision processing? Option A. It converts the images to black and white to save memory. Option B. It aligns the images so that the search for corresponding points is limited to a horizontal line. Option C. It removes any people from the images for privacy. Option D. It increases the frame rate of the cameras. The correct answer is B. Stereo vision uses two cameras to estimate depth by finding the same point in both images. Disparity. Searching for a matching pixel across the entire second image is computationally expensive. Rectification mathematically warps the images so that they appear to have been taken by two perfectly aligned, parallel cameras. This ensures that a point in the left image will lie on the same horizontal row, epipolar line, in the right image, drastically simplifying the search and improving speed. In reinforcement learning for autonomous agents, what does the reward function define? Option A. The amount of electricity used by the AI hardware. Option B. The goals and constraints of the task by providing feedback for actions taken. Option C. The price of the AI software. Option D. The salary of the engineers who built the system. The correct answer is B. In reinforcement learning, RL, an agent learns to make decisions by performing actions in an environment to maximize a cumulative reward. The reward function is essentially the programming of the agent's goals. For example, a car might get +1 for moving forward safely and -100 for hitting an obstacle. Designing a good reward function is notoriously difficult because if it's poorly defined, the agent might find loopholes, unintended behaviors, to get rewards without actually performing the desired task. What does the term V2X communication stand for in autonomous systems? Option A. Vehicle to xylophone. Option B. Vehicle to everything. Option C. Version 2. X software. Option D. Virtual to extended reality. The correct answer is B. V2X. Vehicle to everything is a communication system that allows a vehicle to share information with other entities. This includes V2V, vehicle to vehicle, V2I, vehicle to infrastructure like traffic lights, V2P, vehicle to pedestrian, and V2N, vehicle to network. V2X enables collaborative autonomy, allowing cars to warn each other of accidents around corners, or traffic lights to tell cars when they will turn green, significantly improving safety beyond what onboard sensors can see. What is odometry in the context of mobile robotics? Option A. The study of odors and scents in the environment. Option B. Estimating change in position over time based on data from motion sensors. Option C. The protocol for upgrading the robot's firmware. Option D. A method for measuring the weight of the robot. The correct answer is B. Odometry uses data from actuators, like wheel encoders, to estimate how far a robot has traveled and in what direction. If you know the circumference of a wheel and count its rotations, you can estimate distance. However, wheel odometry is prone to errors caused by wheels slipping on wet or sandy surfaces. This is why it is usually fused with IMU and visual data to create more reliable, visual inertial odometry. VIO. What is the primary concern of explainable AI, XAI, in autonomous systems? Option A. Making sure the AI can speak multiple languages. Option B. Ensuring the system's decision-making process can be understood and audited by humans. Option C. Making the code run faster. Option D. Allowing the AI to explain its feelings. The correct answer is B. Deep learning models are often black boxes, meaning even the engineers don't know exactly why the model made a specific decision. In autonomous systems, if a car brakes suddenly without an obvious reason, it's critical to be able to audit that decision for safety and insurance purposes. XAI aims to create techniques that provide human understandable justifications for AI outputs, which is essential for trust and regulatory compliance. What is occupancy grid mapping used for? Option A. To keep track of which passengers are in the car. Option B. To represent the environment as a set of cells, each indicating the probability that it is occupied. Option C. To plan the route between two different cities. Option D. To monitor the temperature of the CPU. The correct answer is B. Occupancy grid mapping is a common way to represent a robot's environment. The world is divided into a grid of cells. Each cell contains a value, usually between 0 and 1, representing the probability that the space is occupied by an obstacle. As sensors scan the environment, the grid is updated using Bayesian filtering. This map is then used by path planning algorithms to find free space for the robot to move through while avoiding high probability occupied cells. What happens when a control system is critically damped? Option A. It oscillates forever around the set point. Option B. It reaches the set point as quickly as possible without oscillating. Option C. The system shuts down completely. Option D. The system becomes very slow to respond. The correct answer is B. Damping is a property of control systems that influences how the system returns to equilibrium. An underdamped system will overshoot and oscillate. An overdamped system will reach the goal without oscillating but will take a long time. A critically damped system is the sweet spot. It returns to the set point in the shortest possible time without any overshoot or oscillation. In autonomous steering, critical damping ensures smooth lane changes without wobbling. Which layer type in a convolutional neural network, CNN, is responsible for reducing spatial dimensions and providing translation invariance? Option A. Fully connected layer. Option B. Pooling layer, e.g., max pooling. Option C. Activation layer, ReLU. Option D. Softmax layer. The correct answer is B. Pooling layers. Like max pooling, downsample the feature maps generated by convolutional layers. By taking the maximum or average value in a small window, e.g., 2x2, the network reduces the amount of data for the next layer and becomes less sensitive to the exact location of a feature in the image. This translation invariance is crucial because a stop sign should be recognized whether it is slightly to the left or right of the image center. In the context of autonomous systems, what is a fail operational design? Option A. A system that turns off immediately when an error occurs. Option B. A system that can continue to function safely even after a significant component failure. Option C. A system that only works when the driver is holding the wheel. Option D. A system that never fails under any circumstances. The correct answer is B. While fail-safe systems move to a safe state, like stopping, when a failure occurs, fail operational systems have enough redundancy, backup power, redundant sensors, dual processors, to continue their primary mission, or at least safely complete the current maneuver, despite a failure. For Level 4 and 5 autonomous cars, fail operational steering and braking are required because the human might not be available to take over immediately if the primary system dies. Which of the following is a sampling-based path planning algorithm often used in high-dimensional configuration spaces? Option A. Dijkstra's. Option B. RRT. Rapidly exploring random tree. Option C. Value iteration. Option D. Greedy search. The correct answer is B. Unlike grid-based algorithms that search every cell, RRT, rapidly exploring random tree, grows a tree by randomly sampling points in the search space and connecting the nearest node in the tree to the sample. This is particularly effective for robots with many degrees of freedom, like robotic arms, or complex constraints, as it can quickly find a feasible, though not necessarily optimal, path through a high-dimensional space without having to discretize the entire environment. What is the primary benefit of data augmentation when training perception models for autonomous systems? Option A. It reduces the amount of storage needed for data. Option B. It artificially increases the diversity of the training set to improve model generalization. Option C. It deletes incorrect labels automatically. Option D. It makes the model run faster on the car's hardware. The correct answer is B. Deep learning models require massive amounts of data. Data augmentation involves creating new training examples from existing ones by applying transformations like rotation, flipping, brightness adjustments, or adding artificial rain, fog. This forces the model to learn features that are robust to environmental changes, helping it generalize better to real-world scenarios it hasn't seen before, such as different lighting or weather conditions. What is the main difference between local localization and global localization? Option A. Local is for indoors. Global is for outdoors. Option B. Local tracks the position relative to a start point. Global finds the position on a map without a known starting point. Option C. Local uses GPS. Global uses cameras. Option D. There is no difference. The correct answer is B. Local localization, or pose tracking, assumes the initial position is known and focuses on tracking the change in position. Using odometry or IMU. Global localization is the kidnapped robot problem. The system starts with no knowledge of its location and must use its sensors. Seeing landmarks or matching lidar scans to a pre-built map to figure out exactly where it is in the world. Global localization is much harder because it requires searching the entire map for matches. Which sensor is most affected by heavy fog or snow? Option A, radar. Option B, lidar. Option C, ultrasonic. Option D, IMU. The correct answer is B. Lidar uses light waves, near-infrared, which are easily scattered or absorbed by water droplets in fog or snowflakes. This causes noise in the point cloud and significantly reduces the detection range. Radar, on the other hand, uses much longer radio waves that can pass through fog and rain with very little interference. Which is why radar is the primary sensor for weather-resilient obstacle detection in autonomous vehicles. What does latencies refer to in an autonomous systems processing pipeline? Option A, the amount of data stored on the hard drive. Option B, the time delay between a sensor capturing data and the actuator performing an action. Option C, the physical weight of the sensors. Option D, the number of lines of code in the software. The correct answer is B. In autonomous systems, timing is everything. Latency includes the time for sensor data acquisition, processing by the AI, inference time, decision-making, and the communication delay to the mechanical parts. Brakes, steering. If latency is too high, the vehicle will be reacting to where an obstacle was, rather than where it is, which can lead to collisions, especially at high speeds. Minimizing end-to-end latency is a core engineering goal. That concludes our 30-question practice run for the AI Autonomous Systems certification. How did you do? If you found some of the concepts like SLAM or MPC challenging, don't worry. These are advanced topics that take time to master. If you found this video helpful, please give it a thumbs up and share it with your fellow AI students. Your support helps us create more of these detailed guides. For the full bank of over 300 practice questions and a detailed study guide, check the link in the description below.